Hello, hello. I hope everybody got their Advil and their coffee. They're good to go. Maybe a nap in. I could use one. So this is a real pleasure for me. So I met Digit, I don't know, it's been years ago, Texas, I think. And at the time, Digit was building a game in Elixir. It's amazing. You should go find that talk and watch it. But we started talking, and he works for SmartRent, and Digit got the job at SmartRent because he broke into their hardware. So maybe he'll share a little bit of that story, maybe not. Thank you, Digit. Welcome.
All right. I'm really excited to be here. It's been a while since I've given a talk, and thank you everybody for coming out. I hope you're all doing great. All right, so first up, how's it going? I'm Digit. I am a senior firmware engineer at SmartRent, where I build a lot of really cool hardware. I am in love with creative problem solving. If you give me a problem and you say you have nowhere to start, it's perfect for me. It's what I like. I, on the side, maintain the Elixir Burrito project, if you are familiar with that. Thank you. That's been a love of mine for a while, so if you don't know what it is, it's just a way to package up Elixir applications into single executables. I really love playing with embedded hardware, and I'm really happy that I now get to do that as my career. And I always feel like I always got things to learn, and that I always never run out of projects. That's both my weakness and my favorite aspect of my life. So let's go over what we're going to talk about. I'm going to quickly go over what we do at SmartRent and some of the custom hardware and some of the custom pieces that we build. And then we're going to go over the high-level architecture of Flutter and get into a little bit about what it is, why we picked it for this product that we were making, and why we didn't pick some other solutions. I'm going to talk about the journey of how we went from a piece of hardware with no firmware on it that we got from a factory to something that we're installing right into people's apartments now. And then I will have a very cool live demo that I am 100% sure will work. And then I have some cool open source news, so watch out for that. All right, so engineering at SmartRent. First of all, shout out to everybody at SmartRent who's either here in the audience or watching live. Basically, all we do is we design enterprise-scale smart home solutions for multifamily housing, apartments, condos, new build houses, all those kinds of places. It's a kind of, we like to call it the gateway drug to smart homes, because everybody kind of walks in and they get a smart lock, and now they can kind of play with it. We primarily utilize Z-Wave smart devices. It's a sub-gigahertz frequency. We deploy everything using a 4G backhaul network. It's all MQTT-based. We use a lot of nerves. Almost all the hubs we've been installing recently are running nerves firmware. There's thousands and thousands and thousands of devices that are running nerves out there. It's so cool. And a lot of custom hardware that has been designed by us and our partners at Zapato. It's a lot of fun. This is one of our custom pieces of hardware. If you saw Frank Hundlitz's talk at another Code Beam, I think it was last year, he had a couple of these devices and talked about this one. This is the Hub Plus. It is actually a thermostat and a smart home hub, all in one device. It's only about the size of like a hockey puck, and it replaces your thermostat. And the reason we did that was because the thermostat is in a good cellular reception area. It's right in the middle of the room, probably a lot of windows, because we had problems where people were putting hubs behind refrigerators and in like metal cabinets, which wasn't great. And also, we already have power there, so we don't have to worry about powering the hub and getting an outlet, because there's already 24 volts VAC running through your thermostat system anyways. So it was kind of a really fun solution. This thing is actually a very cool little tiny Linux machine. It's running an SoC called the Allwinner H3. It's a 32-bit ARM CPU. It has the smart home hub capabilities. It is also a thermostat. It has a LED indicator display, so it's got like 7-segment and all that. It's got 4G LTE. It's got 2.4 gigahertz Wi-Fi, Bluetooth, and BLE support. It also has the Z-Wave antenna. The 2.4 gigahertz can also be used for Thread in the future, potentially. This is the piece of hardware I really want to talk about, though, because this has been kind of my life for the last like 2 years. This guy is the Fusion 3. It is running an Allwinner A64. This is a 64-bit processor, so a little beefier. It is a smart home hub and thermostat, just like the Hub Plus. It has all the same radios, but the one thing you'll notice is that it also has a gigantic full-color multi-touch display. This is a very cool device. And of course, we needed to get some UI onto that. What we decided to use was Flutter. give you a little demo. This is the UI we built, and it can do all the things you would expect a normal thermostat to do. You can change the fan mode. You can go ahead and change all the modes from heating and cooling. Of course, you can do all HVAC right from this device or from the SmartRent app. You also can control all your devices from here, so you can adjust dimmers, you can unlock and lock locks, you can check the status of leak sensors and other contact sensors, and you can control all your Z-Wave devices right from this little guy. So even if you're offline, you can go ahead and tap around. Got things like settings, multiple ways to connect it to the internet. It actually has Ethernet built into the back as well in case we wanted to run some wired Ethernet to this thing. But cellular, LTE, all that good stuff. The high-level hardware stack looks like this. It's nerves, so it's running a fairly mainline kernel. Thanks to Frank for keeping that up to date more than most embedded projects. I really appreciate it. We use a open source library you can find on our SmartRent GitHub called Grizzly to help facilitate the communication between Z-Wave. We use AWS IoT and MQTT for bidirectional communication to and from the hub. And of course, we're now using a Flutter UI to communicate with a backend, which is actually on the same device, to a front end. But all that said, what even is Flutter? OK. Flutter is actually an open source user interface framework. Google invented this quite a while ago. It actually utilizes the Dart language. I don't know if anybody has an experience with that, but it's an object-oriented, virtual machine-based language. It's kind of interesting. It can actually target a ton of platforms. So it's like Windows, Mac, Linux, iOS, Android, mobile apps, WebAssembly as of recent, and just straight web. I find it extremely productive to make really nice-looking UIs really quickly. And it's even used internally at Google for some fairly notable things, like even the Play Store itself. You've probably used an app that uses Flutter. If you recognize any of these things, you probably used Flutter. And you can generally get a feel for the range of apps from this little promotional image they had on their website. It's basically anything. At the architectural side, this looks like a lot. It's at the top, you have this crazy Dart framework that handles all your high-level user interactions. It's got animations and painting and touch gestures are all built in. That's all in Dart. Below that is your engine. This is all in C++ and C. What this is just kind of lower-level protocols. This is still cross-platform because while you think this is a lot to port to a new device, you really only need to care about one thing, and that's this part on the bottom down here. And this is called the embedder. That's all you need to implement. What that is your event loop, what graphics platform you want. So you could use OpenGL, you could use Vulkan, you could use software rendering if you wanted to have a slow time. Anything. So that's all you really need to implement. So we were looking at this and we thought, well, great, well, OK, it's still a little bit of work. But luckily, there's already embedders, and there's a lot of really good open source ones. There's one called FlutterPy, which, as you could guess, is centered on the Raspberry Pi. It works straight out of the box. It's a really cool project. We actually utilized this one for a while. There's also one by Sony. I don't know what Sony uses it for. I should probably figure that out. But they maintain it, and it is super up to date with the latest version of Flutter. It's a really cool project. It is specifically targeted for embedded Linux devices. Hooray. So why did we pick Flutter, you might be thinking? Well, the toolset is really mature. It's basically download and go. For the most part, it takes no effort to set up. It has a really huge community of packages. If you want fancy loading animations, you can grab them off. It's called pub.dev. That's their package manager. You can find tons of really useful packages, full pop-up keyboards in case you have a device that doesn't even have one. Anything. The material design, which is Google's new modern UI design system that they came out with, I think, a few years ago, is built into it. It's already there. You make a button, it's going to have that splash effect. If you don't want the splash effect, you can customize it. You can change all the colors. It's very customizable, totally stylable. It's easy to embed. We are using Linux. We want this thing to just boot up real quick. So why not something else? Why not an embedded browser? I'm sure a few of you are probably thinking, why didn't you use React Native? Why didn't you use React? Why didn't you use a web app? Well, first of all, this thing only has 2 gigs of RAM, and it's a SoC that, while fairly powerful, we downclock quite a bit. The reason we do that is to not generate as much heat. We don't want to use a lot of power. We don't want to suck up a lot of power off the HVAC system because that can cause problems. But the Beam is really, really good at running with like even a few hundred megahertz. It's really impressive. So we downclocked things as much as possible. So an embedded web browser was not really going to cut it. On top of that, there are way too many dependencies. There's a spelling error in there. Whoops. There's way too many dependencies in there. We really wanted to keep the firmware ranges slim. Bytes over 4G are not free. And so the more we have to push over, the less happy we will be. On top of that, we would have to ship a whole display manager. We probably would need the X server. We would maybe need Wayland or something. Again, more dependencies. That's bad. And of course, it introduces a ton of vulnerability surface area. So I don't know if you've ever popped WebKit into the CVE database, but you get some good times. Most game consoles are broken, usually through an entry point in the JavaScript engine. So we didn't really want to expose that. Why didn't we use Qt or Qt, depending on how you like to pronounce it? The licensing is really complicated, confusing, and expensive. On top of that, we are a small team internally at SmartRent that's building this custom hardware. C++ is not really a very productive language, in my own opinion, but that's because maybe I haven't written it for most of my life. But getting up to speed with Qt's version and flavor of C++ can be a little rough for a team that's not super experienced in it. On top of that, there's still a ton of dependencies we would have to ship. And again, we would need a display manager. They do have that embedded version, but it is not as fancy and doesn't look as nice. I think it's more geared towards like automotive stuff. Why didn't we use Scenic? First of all, we love Scenic. It's wonderful for HMIs and wonderful for small personal projects. But again, we're a small team. We would have to build out a ton of components that aren't there yet. That's fine. And we also had a lot of questions around how we would do multi-touch gestures. Most people, when they pick up a touchscreen device, are going to expect it to operate like their phone or like their iPad. So we needed an experience that really matched what a consumer would be expecting. Remember, people are just going to have this installed in their apartment, whether they kind of want to or not. But we wanted it to be a good, enjoyable experience to actually use the UI with every modern facility you could think of. So now we got to build an MVP of this thing. How did we do that? First, we had to select an embedder. There's those two open source ones I had pointed out before. There was FlutterPy. We used this one for a while. However, because of how it was operating, we had to compile that engine component, that really big, chunky C++ section, every time we had to build a new release. This took a long time. This took a very long time. It was not fun. It kind of shaved a lot of hours into our CI, which was we really wanted to kind of avoid that. I had to hack out libsystemd. It was just built into the embedder as the event loop provider. I replaced it with libuev, which is lib micro event loop. If you're looking for an event loop library in C, that's like dead simple. It's really good. So kind of had to hack that out. So now we have a fork of it. This did work for a while, but now we have our own fork, and we did end up contributing some stuff back, but maintaining it, again, for a small team wasn't gonna fly currently. So we turned towards Sony's embedder. Sony's embedder was really up to date, just like FlutterPy, but it didn't cause us to recompile everything every time. They provided pre-built, statically linked SO libraries that you could just pull down. So it was really easy. It shaved off that hour and 55 minutes down to like 40 minutes, which is more what you would expect when building an entire nerve system, because it is still the whole Linux kernel and a bunch of other stuff. Both of these, of course, required us to interface with buildroot. If you've ever made custom build systems in nerves, you know you need to use buildroot because that's how we compile the kernel and how we manage dependencies. So we do have packages we wrote to pull these into our buildroot system, and they are open sourced and up there. Both of these actually are using direct rendering, which means we don't need X. There is no X server, there's no display manager. We are just using the hardware accelerated frame buffer. It's awesome. Now the next problem, how do we talk between these two? Dart is in another VM, Elixir's in another VM. How do we get these two things to communicate? We had a first attempt that we did. We needed some kind of RPC-like interface, but we wanted a typed contract between the two. We didn't want them drifting apart. The first thing we actually did was a GQL, because there was some mature support in Flutter for GraphQL, and there's mature support for GraphQL in Elixir via Absinthe. We used Absinthe on the Elixir side to generate the schema. We generated the schema, we put that in Dart. Dart would generate a bunch of typed code, so we got really nice editor suggestions and type checking at compile time, which was awesome. The resolvers on the firmware side would reach out to the different components because the firmware is built up of a ton of different systems. There's the Z-Wave side. We might have to go query a device. We might have a device cache so we don't flood the Z-Wave network with tons of requests. We would have to talk about how we could get weather data. So we just build out some resolvers, and depending on your query, we would reach out to the specific firmware component and resolve the request for the front end. And then, yeah, Dart utilized code generation. There's a lot of code generation involved with GraphQL in the Dart side because Dart didn't have macros. It does now, but it doesn't. It didn't when we started this project. That said, I can't deny that we had some issues with GraphQL. We are planning a future second attempt at this RPC interface. The problems we were running into is that GraphQL has kind of way too much overhead after we started playing with it and started deploying it. Queries were taking kind of a little too long. We felt like we were reaching the limits of the Flutter GraphQL client, which was a little unfortunate. And we were having some issues with absent subscription latency. I think there was like a minimum 250 millisecond back and forth between something being published. We were trying to figure that out with them. Couldn't nail it down exactly. We're actually going to move to protobufs and gRPC next. We've done some experiments with it. I know you might be saying, like, well, that's complicated, but protobufs are the same thing. It's a schema. You define it. It generates code. And then everybody talks the same language. That's all we need. My personal pipe dream, however, and I don't have anything to prove this, but I would really like to have a Dart node. I started writing the Erlang distribution protocol in Dart, and I got the handshake part going, but I need to move on to the next, like actually exchanging information and all that. I got it showing up in EPMD, but that's about as far as I made it. But that would be my really, really like ideal communication mechanism for this. Here's a really cool thing. Because we have defined an RPC interface, and because we're using it as a front end and a back end, you can do remote development. That means you can run this RPC server in two modes. Closed, which is how production firmware is automatically configured, which is it listens to localhost and you just kind of talk back and forth over that socket. We actually used a Unix socket at one point just on the file system under temp. And then there's open, which actually binds this RPC server to your LAN. What that means is you can run, because Dart is cross-platform, you can run the front end on your computer, rapidly iterate on the design, and use a physical real device that's providing real firmware data as your back end. And so you can just really rapidly, without flashing anything or copying anything over to the device, just bang out UI components all day. And it really accelerated the development. You can control the physical device remotely, which was really fun because I had the thermostat on my wall and I was developing the little thermostat flyout menu and I was just like changing my HVAC on and off all day. it was pretty fun. This is what this looks like. It's actually, this is it running on my MacBook at work, and there's the whole UI just in a Mac OS window running, talking to a real device. You can even see there's like a tiny little device is sleeping on the bottom because otherwise we blank out the screen when it's sleeping, but it's just so you know. I have a demo to show, and it's going to preface some of the next things I'll talk about. This will either go really well or really badly, but I think it'll go really well. So you can't really see it up here, but I have a Raspberry Pi 5 and a touch screen, and I have it running through a capture card here. This is a real Nerves Flutter demo that's going on that I built out just for Codebeam. So you can do some things you would expect. You can go and read some device info. I know it's a little small. I wish I could make it a little bigger, but the capture card doesn't quite scale it. That's just a basic list menu. Whoops. You can do things you would expect, like scan for Wi-Fi networks. Hopefully nobody has any funny names. But this is a menu you would expect to be present in a modern device. Oh, there's actually no Wi-Fi networks. That's interesting. Might have gotten overwhelmed. Of course, I wanted to show some demos of how nice and smooth you can actually use Flutter on this embedded device. Yes, it is a Pi 5. It is pretty powerful, but this has also been tested on Pi 4, and most ARM64 devices are going to be able to run this pretty well. In fact, just to show you, I'll toggle a performance HUD real quick and go back into my animation demo, and you can see we're maintaining a fairly consistent 60 frames per second, barely even touching the CPU load. So it's working pretty well. All right, let's turn that off. Another fun thing I wanted to show off was that, yeah, you can stream logs live from or have a stream going. I just have a gen server that's spinning out monotonic time every few seconds, but that's just to show a live streaming data coming from Elixir going right into the Dart VM, and so you can just have real data coming in real time, because we need that for all of our little devices. And then, of course, just to show it off, we have modals, again, all built into Flutter. Yeah, so that either went really well or really badly. I think it went all right. Okay. So how? Like, get a little more technical, I'm sure. You probably want this. So there's two things that are involved in this. There's one library called Nerves Flutter Support, and there's one called Nerves Flutter Example. Nerves Flutter Example is what I just showed you. It's that firmware all in one with the Flutter app, everything all packaged up together. Nerves Flutter Support is a bunch of runtime libraries, including the embedder, which is Sony's embedder that we pull in, and a couple custom patches we had to make to some runtime libraries, because base Nerve systems don't ship with libdrm or libegl or any of those things. Usually, you would have to build a system for that. If you know Nerves Kiosk, that's a totally different system you have to pull in and build and maintain. This is not the case with Nerves Flutter Support. There is no system. This is dropped into the base RPi 5 system or RPi 4 system. There's no additional things. In fact, I've seen this run on other ARM64 devices. This is just a hex dependency. You can pull this in, and now you can create a Flutter app and have it running on an ARM64 Nerves device. You can use it with virtually no changes to your existing system, unless you have some weird library conflicts. That includes the RPi 4, the RPi 5. We provide all the pre-built artifacts. We pull them down off a CDN for you during mix compile and mix firmware. Don't have to worry about anything. It also provides a lot of gen servers and child specs to help you kind of get the app up and running. Goes through muon traps, so it's supervised. If the UI dies, it gets restarted automatically. All that good distributed system stuff we all know and love. Nerves Flutter Example is an up and running quickly example that you can take a look at. I'm just going to go pretty quickly through this, but the big thing I want to point out is this is the gRPC Flutter backend that I was talking about. It does work really, really well. It's tested on RPi 4, RPi 5, and this guy, Lars, one day told me, hey, I got that running on another device, and brought it here, which was really nice of him. So he's running on an actual Clockwork. Really cool. Thank you so much. Did that in like a day. I was not expecting it. All right, so how did we make this without a system? Well, the secret sauce is build root again, but not to build the whole system. All I did was build a root file system with all the libraries using the same Nerves tool chains that we use for building all the other systems, and then just kind of plucked out the things I needed in the same shape of the rest of the root file system. I fetched the Sony embedder. I apply a few questionable patches to some libraries because there's some hard-coded paths I had to change. And then I pack them all up into an archive. And then I do some really fun dynamic linker tricks. At runtime, every library is located in Nerves Flutter Support's priv directory. I use LD library path to override what the embedder is going to look for those libraries, and done. That's it. It's actually not that hard. It feels a little hacky, but it works really well and has never broken on me yet. If you ever want to get the idea of what this looks like, here it is. Down here, you can actually see I'm just passing in some environment, and you can see right there, LD library path is just the lib path, and then the existing library load path. I love embedded Linux. You can hack it to your heart's content. If you wanted to get started with this, all you really got to do is add this to your existing RPi 4 or RPi 5 firmware project. You can create a Flutter app by using flutter create Flutter app. If you leave it as Flutter app, that means you don't have to change other configuration because it expects it to be in that folder, but you can configure that if you want. The exact version of Flutter will kind of increment with Nerves Flutter support, so that'll be kind of that'll be signed pretty well. And then all you have to do is add one more step to your mix release. You already have a Nerves mix release project, so it's already in there. Just add one more line right here. Add Nerves Flutter support, build Flutter app. And again, if you want to configure where your Flutter app is being pulled from, if you have it in a separate repo, you can do that with more configuration options. Otherwise, it just looks for a folder called Flutter app. And if there's a Flutter app in there, it'll automatically grab it, compile it, put it in your firmware, and you're good to go. If you've never seen what Flutter and Dart looks like, here's a really basic widget. This is that Nerves logo that showed up at the very beginning. We use Nerves hooks, we use Flutter hooks. The reason for that is because it's familiar. If you've used React hooks, it's basically the same thing. Helps you manage your state pretty well. Some little tips I like to say is that we keep things stateless. We avoid the stateful widgets. We instead use hook widgets, which are stateless, technically. All it really does is help you manage it. Flutter hooks are big key things. We use SVGs because if we want to support more screen resolutions, we'll want to support different resolutions for our icons and logos, and all those buttons are all SVGs. Try to avoid multi-level inheritance. Dart is an object-oriented language. Just common pitfalls for OO languages. Just watch out. Walk you through this. We're extending the hook widget. Every widget is going to have a constructor. It's also going to have this build method. This is just like, if you're familiar with React, it just runs this over and over again to build the new version, and then hooks will cause a rebuild. And that's really it. If you want to use that in anything fancier, you just return it, and then in another context, you can see I'm pulling that and wrapping it in a fade in so that it has a nice animation as it fades in, and then wrapping it in a bunch of row and column layout code. Again, everything in layout is handled by Flutter. You just put it into the widget tree, and it'll reflow everything for you. What it looks like at build time is this. If you're on Mac OS, you have to use Docker. I'm sorry, this is a weird Dart limitation. So I sped this video up a little bit because it takes a little bit to compile the Flutter program. Hopefully that'll be fixed in the future. That's it. You don't have to do much more configuration than what I just talked about. It's pretty simple to get up and running. And you might be thinking, well, when can I use this? I'm going to be publishing the hex packages today, later today. If you want to look at the code, it's already on GitHub. It's already public. Both Nerves Flutter support and Nerves Flutter example are open and ready to go. You can pull them down, flash them onto your Raspberry Pis. I've tested them on Raspberry Pis. I've tested them on Pi 4 and 5. If it works on other AH64 systems, please let me know. If it doesn't, also let me know. And that's all I got. Thanks. I don't know if we have any time for questions, but that'd be pretty good.
I'm really bad at turning on the microphone.
Hey, thanks for the talk. I have a question about the message format. Have you all considered using the concise binary object representation format, the CBOR?
I have not. I've not considered that. That's a good thing. I'm going to look into that. Thank you.
I want to know where you got all your dogs, because they're awesome. Your
All those
characters.
are drawn by my partner.
Nice.
All the art was drawn by my partner.
That's
Yeah.
awesome. Anybody, anything else? No questions? I didn't see any online. I'll double check
All right.
before we. All right. Well, I guess
Awesome.
that's
Thanks.
it. Thank you.